radius in of G with latitude. Observe the earth, its radius is r, and phi is the angle with horizontal line, and r is the perpendicular distance between axis of rotation and the position p. Let us suppose say the particle mass is m. So from the figure we can say that angle we can relate with r and r in such a way cos phi is equal to r by r. Cos phi is r by r. Now from that small r is given by capital R into cos phi. Capital R into cos phi. Now here you need to know there are two forces acting on the particle. One is because of the rotation, angular outward velocity. So that angular velocity always gives centrifugal force, as well as the inward force towards the center of the earth, that is its common gravitational force. That common gravitational force is given by, let us suppose, Fg. So that Fg is equal to G capital M small m by r square that is equal to simply mg, the weight of the body itself. So the second force acting on that one is centrifugal force. This centrifugal force is always acting outward. So now that centrifugal force is, if it is dominating, indirectly that is nullifies, decreases the force of attraction, the weight is indirectly decreases. So that is given by m r omega square. For your kind information here, small r, this is not the capital radius of the earth, it is the perpendicular distance from the axis of rotation, small r is. Now you need to know these two forces are having two different directions. They are not on a line, an angle between them. So depending on that, resultant force will depend on it. Why? Because this is a vector. So the resultant vector is always given by root f1 square plus f2 square plus 2 f1 f2 cos theta, angle between the two forces. So similarly here two forces, centrifugal force and centripetal force, by using parallelogram law. If you take the figure, when you observe that figure, so in that you need to know the forces acting on that body. One force, gravitational force, directly towards the center it is acting. The outward force, centrifugal force, is always in the direction of r, small r. So now away from the axis of rotation. So that is given by mr omega square, we know that. Now if you draw this, that circular path in which it is rotating because of the angular velocity of the earth, the body can also having the same angular velocity. And similarly, if you draw these two vectors, so like a parallelogram, so then the resultant force also. So for that we need to know the angle between them. So that is, if the angle phi is around, if you extend that angle between these two, if you extend that line, then the angle between the centripetal force and that line is phi, and the remaining angle is 180 minus phi. So this is the angle between the inward force and the outward forces acting on the body. Now if you draw a parallelogram, so then we can know that the resultant force direction also. Now if you take parallelogram, that is root a square plus b square plus 2ab cos theta, 2ab cos theta. So under the same formula I am using the two forces squares plus 2 force 1 force 2 into cos angle between the two forces. Now that is given by again, so m square g square g square. So now that is under root, you can take m square g square plus m square r square omega power 4 plus 2m square g r omega square minus cos phi. The reason minus cos phi came because the cos 180 minus phi is the second quadrant, that is negative. So you can write minus cos phi, minus cos phi. Now after the next step, you can take the common factor here, m square g square as common factor. Then you will get, you can take it out also, that is under root. Then under root, that is 1 plus m square r square, that is omega 4, not omega square for your. Now you can cancel this m square and m square and 1g. So now the remaining things you can write the leftover things in the under the root. So that is before you need to know another relation, that is r equal to r cos phi also we derived in this is in the starting of the topic. So now we can write that is r square cos square phi, that is omega power 4, sorry for that here. So now g square plus 2r omega square, of course minus you can write in front if you need, cos theta, cos phi, sorry, omega square by g into minus cos phi. Now again here mg root, you can get scan here. This is the, because of the power is very negligible, you can neglect the second factor, which is r square cos square phi omega power 4 by g square. So now only one term inside, we have that 1 plus or 1 minus 2r cos square phi, that factor only. Now here the term r square omega power 4 cos square phi by g square. So sorry for that, that is small error, that is omega power 4, okay, omega 4 by g square, so that is very less than 1, very less than 1. So we can neglect that one for convenience. If you need the original value, you can use the full factor, like that you can use, okay, then you will get accurate value. So but that will not give much difference, so that is the reason we are neglecting that factor, that term. Now fr is equal to mg under root, so mg under root 1 plus 1 minus 2r omega square cos square phi by g, Now again here by using binomial expression, okay, or distribution, so we can distribute the thing. Why? Because that 1 minus x whole power 1 by 2. So here this is very small when you are comparing with the 1 again. So now we can take the distribution, so that is power 1 by 2 n into the first term only we can take, okay, the second term only. The region, the higher order terms will be negligible again, negligible. So now that is equal to 2 gets cancelled here, 2 gets cancelled here. Then you will get that is equal to mg 1 minus r omega square cos square phi by g, cos square phi by g. Now the net force mg 1 open bracket 1 minus r omega square by g. Now the mm gets cancelled, so g minus r omega square cos square phi is the effective acceleration due to gravity at an altitude having angle phi, okay. That is the end of the derivation. Now see, if the phi is 0, so where that is at equator, so at equator it is very less. So at poles it is maximum. At poles phi is 90 degrees, so at poles it is maximum, okay. You need to know these two conditions. At equator it is very less because the outward force is more, so that is the net force is less. So where the outward force is very less at poles, so that is at that poles it is maximum.